Yeah.
My guess is the only one that might have given you trouble are, things that we had to like do the simplifying level 3 stuff here. And then maybe some stuff on the back with multiplying. I don't know. Like, do you want to go over anything? Do you want to see anything again? Because if not, I'm just going to pick up multiplying because I only gave you the 2, right? Yeah. I want to start with those 2 if there's nothing else you want to see. Like, do you want to know the answers to make sure you got them right? Or
he went around, he checked all the parts and then gave it back. Mine and Brianna's yes.
Okay. Then let's just do this real quick just to make sure we've got it. So if you have this, take it out from yesterday. I'll read aloud the answers. You can see if you got them right. Put a little check mark next to them so you feel pretty good about it. If there's something you got wrong and you know why, then fix it. If you're not sure why, then we'll figure it out. Just making sure that we can get to this A plus BI. And again, sometimes A is just 0, sometimes B is just 0. Sometimes we need plus or minus because we're solving something. So the front and the back, very different, right? Front is solving equations. The back is just adding, subtracting, multiplying. And then I'll show you division, and I think that will end up being the last thing we do, is learning how to divide 2 complex numbers, because it's just a different kind of process. And so we'll see how it plays out. If we can get to division today, great. If not, that's okay. We'll do that next time. But next time with me is not tomorrow. Okay, baseball's in Grand Junction, so I'm leaving tomorrow morning. And so you'll have a sub tomorrow. It'll be a fairly easy day, maybe something similar to this, but just focusing on multiplication, maybe division. And then next week, we'll go like Monday, we'll practice, make sure we're feeling good with it. Maybe Tuesday as well, because division's trickier. There's more to it. And then like Wednesday, Thursday, maybe, or Tuesday, Wednesday, or something like that, we'll do our 2 quizzes. Okay, we'll do our 1 for completion effort and then 1 for correctness. And then we can start review Friday. We'll have Friday, Monday, Tuesday to make our note card and get a review and practice and things like that. So that when we get to the actual final, which is Monday, I think, right, 5th, 6th. Yeah, Monday the 24th is the day of our final. So you'll have a note card ready to go by then. You'll have lots of practice. Okay, so let's take a look at this, and I'm just going to read them aloud. Let me know if you have questions. Number 1, x equals plus or minus 5i. Number 2, x equals plus or minus 8i. Number 3, x equals plus or minus 12i. And then, yes, even decimals have perfect squares. X equals plus or minus 2.5i. Okay, there should not be a square root in that answer. And that's why I tried to make it super obvious. Level 1, perfect squares. Even the decimal in there could be coming from something perfect. Okay, so 2.5. Level 2. Number 5, x equals plus or minus the square root of 5i. I on the outside. Okay, if you put the I in front of the square root or after, either one's okay. Number 6, x equals plus or minus the square root of 11. I after. Number 7, x equals plus or minus the square root of 14. I. Again, I can be in front or after. We like to keep the I at the end because that's kind of our goal, A plus BI, right? We want the I to be last so we know it's coming. Okay. 8, 9, 10 is where it gets a little trickier because there's just some simplifying we can do, but I tried to make that obvious. Okay. So square root of both sides, right? So we get to 20, which is 4 and 5. So eventually we get down to x equals plus or minus, woo, fresh haircut, looking so good. I like it. X equals plus or minus 2 square root of 5 I. 2's on the outside, 5's on the inside, I after. Just going over answers to yesterday's. Number 9, right? We could split the 45 into 9 and 5. So x equals, question first.
Yeah, so does it matter if we put like 2i squared root 5 or do you want it?
The goal is to put the I at the end. Okay. That's standard form for complex numbers. It's not wrong. But it's like writing like 2x as x times 2. Like not putting the constant before the variable. It's not wrong. It's just not in the form that we like it in. Because it's harder to deal with, I guess. So I'm not going to take points off. If you go 2i root 5, that's fine. But know that the goal is to put the I. All right, so number 9, plus or minus, x equals plus or minus 3 square root of 5 I. And then last one, 75 is not perfect, but does have a 25 factor in there. So x equals plus or minus 5 square root of 3 I. So, yeah. No. Any questions on the front? Feel like that went okay? Feeling pretty good about it? Okay, cool. Because that was that's the thing we've been doing for a few days now. The operations I know was really just one day. Was that just yesterday? Like Tuesday? Right? That was it, right? So so this might have been a little bit trickier, but hopefully level 1 stuff was pretty easy because we're just adding, so things should go together pretty well. So number 11 would be 6 plus 11i. All right, a plus bi in that order. So 6 plus 11i. No negatives there, so nothing to watch out for. But 12 and 13, we do have some negatives, so we got to be careful. Real parts together, imaginary parts together. So 12, 3 plus 10i. And then number 13, negative 2 minus 9i. Right, because that I, that negative I, right, it's negative 1i. So you got negative 1 minus 8, so negative 9. And we're just adding and subtracting. You're just putting numbers together. It's kind of moving along the number line. 2 negatives don't make a positive when you're adding and subtracting. Okay, you're just putting some negatives together, which is just going to be even more negative. Okay, questions there? Level 1? All good? Sweet. All right, level 2, subtraction. So now what I think is okay is to just kind of like do the real parts together, keeping track of the subtraction, doing the imaginary parts, or taking a step and like distributing the negative in to the second set of parentheses. Either one's fine. You can jump right to the answer if you want, which would be 4 minus 2i. All right, 7 minus 3, and then 2i minus 4i. Okay, so the subtraction is going to happen to everything inside that second parenthesis, so we got to be careful. Which is why 15 might have been even trickier, because you have subtraction and then you've got some negative stuff that you have to deal with. So in my mind, when I look at 15, I'm going to do 3 minus 8, right? The 3, the subtraction, and then the 8, which is negative 5. But then I'm going to do negative 4i minus negative 10i. And that minus and negative, right? We got 2 negatives next to each other. We're going to put those together, and it's going to be a plus. So negative, it ends up really being like negative 4i plus 10i, which is 6i. So negative 5 plus 6i. That's how that's going to work out. Okay. The multiplying is where we're going to start. Okay, so I want to work through the multiplication with you for 16 and 17. I'm going to leave this one up because they're all going to work out the same way, which is really nice. We just have to watch ourselves a little bit, because if we can multiply, then we can divide. If we can add and subtract, we can divide, which is why I saved division for you. So this one's going to be number 16. I tried to start easy with all positive things here. Good, I'm recording. Okay. 2 plus 4i times 3 plus 2i. Okay. How do we do this? How do we go after this? I love that. When I ask the question, like 8 people like start conducting in the air. Absolutely. Distribute everything from the first into everything from the second. Okay. 2 things in the first, 2 things in the second. So 4 arcs, because 2 times 2 is 4. So we should end up with 4 terms as we go. And I just kind of do like, I'll take care of the 2, then I'll take care of the 4i. Order doesn't matter. As long as you keep track of your signs, you're good to go. So 2 times 3 is 6. 2 times 2i, numbers with numbers, so 4i, right? 2 times 2 is 4, and then you have an I attached. Nothing can change there. Plus, and every time I do another arc, I'm going to put a plus or minus in between, depending on the sign of the answer. So 4i times 3, okay, cool. 4 times 3 is 12, and then I, because there's no other I to multiply with it. And then 4i times 2i, well, now I got a couple different i's. So numbers with numbers, 4 times 2 is 8. And then I times I squared. And there it is, 1, 2, 3, 4 of them. So I feel like I got every piece that I needed. And that's the most, because every complex number only has 2 pieces to it. So we're good there. Okay, now, but I know that I can only end at most with the power of I, so we got to think about what that does. Negative, right? I squared is negative 1. Which means I can automatically say, okay, oh, plus 8i squared? Nuh-uh, negative 8. Because I squared is negative 1 and it's being multiplied in, I squared is always going to disappear and change the sign of whatever you've got. Because all we're doing is multiplying by negative 1. Now that I do that, now I can put things together. Real stuff together first. 6 minus 8 is negative 2. And then 4i plus 12i. 16. It's not like it's x equals anything. We're not solving anything. You're just simplifying some kind of operation with numbers. Solid. And that was the new stuff, so I know it's going to be a little bit trickier maybe. And division will be even more new, I guess you could say. Once all right, 17. A little bit trickier only because we have a negative in there, but I tried to keep the numbers fairly small. 1 plus 3i. And then 4 minus 2. Again, same idea. Just distribute, multiplying everything from the first through everything from the second. And again, every time I do one of those arcs, right, once I follow one of those paths, I'm going to put a plus or minus in front depending on the sign of whatever. And it's times. 1 times 4 is still just 4. It's not 5. We're not adding things together. But now, when I do this 1 times whatever's over here, the sign in front of the numbers I want to keep track of. So in my mind, I'm doing like 1 times negative 2i. Which is negative 2i, so minus, right? The sign in front is the one that I want kind of to match up to whatever I'm doing. Good, 1's taken care of, and no big surprise, multiplying by 1 didn't change anything about these, but the 3i certainly will. 3i positive times 4, so 12i. Plus in between, because positive. And now a positive 3i times a negative 2i, numbers with numbers, positive 3 times negative 2? Negative 6. I times I squared. And then I said, well, hold on a second. I know I can't end up with an I squared when I'm done, or an I cubed, or an I to the 10th, or whatever.
So you do the negative thing, but wouldn't that change that to a positive?
It certainly would. Plus 6 instead. Okay, the I is gone, and the sign changes. And the number doesn't, right? Just the sign in front of it does. And I like to do it this way, so I'm not like wasting a whole line of work just doing I squared. Now I can say to myself, all right, I'm just going to put the real parts together. 4 plus 6 is 10. And then negative 2i plus 12i. So you're starting at negative 2, and you're adding 12. 10, yeah, plus 10. And it's just kind of coincidence that those numbers happen to be the same. I definitely just make this stuff up at like midnight. Ooh, this looks good. But there we go. Anybody get both of those right? Nice, that's awesome. If you did, great. If you didn't, but you could follow what we just did, awesome. Then we're getting in good shape. And what I'm going to do now is I want to do one more example, just of multiplying, because now you get the habit. You know what we're going to do tomorrow? Again, will just be kind of a practice day to help you kind of like lock these ideas in. So we'll have classwork 2.4b, which will be our last classwork of the year. Okay, last classwork of the year will be tomorrow in my absence. But there's one that I want to do, and so I say, you know what? You got space at the bottom. If you got space on the bottom of this page, let's just do one more. Okay. After this, though, we'll jump back into our notes so that I can show you division. So I guess the choice is really yours. If you want to do this one on the bottom of this, or if you want to jump into your notes, that's cool too. Yes, sir. Yeah. I'm going to close this behind you. Okay. Cool. So choice is yours. Jump back into your notes or at the bottom of this page. I want to do a very specific example to show you something that happens if they give us a setup where the two complex numbers that we're multiplying together are really, really, really similar. Not exactly the same, but really similar. Okay, and this example is super important as to why we do what we're going to do with division. And you'll see that the thing that I'm about to teach you with division in like 5 minutes is something that we use. There's a style of attacking a problem with division that we just can't handle that works with a lot of different problems that we run into in math. Okay, and here's the problem. Okay, two different complex numbers being multiplied together, and I'm going to choose the exact same numbers in the exact same order, but I'm going to have opposite signs in between. Now, the only reason that this is going to work out the way it does is because of that setup. Okay? Like, if the numbers were different, not going to work out. We're going to end up with a plus bi. Okay? If this was a -3 and this is a +3, like if the sign in front of the first numbers were different, this wouldn't work out. Okay? It's got to be the same numbers in the same order, and the sign